Prepare to rethink everything you thought you knew. This is Mind Benders, your source for the most mind-twisting facts that will expand your understanding of the world. Let's bend some minds.
The hook and the enigma. Everything you think you know about our place in the universe is built on a simple, elegant idea: expansion. After the Big Bang, everything began flying apart, and it continues to do so. Galaxies, like rafts on a cosmic ocean, drift away from each other as the very fabric of space-time stretches. But what if that's not the whole story? What if, while you are watching this, our entire galaxy, the Milky Way, with its 400 billion stars, our sun, our planet, is being pulled, dragged against the universal current by an unseen, monstrous force towards a destination we cannot see? This isn't science fiction. This is one of the most profound and unsettling truths in modern cosmology. For decades, astronomers have been tracking a mysterious anomaly, a flow, a great cosmic river that has captured our galaxy and 100,000 others in its gravitational grip. We are moving at a staggering 1.4 million miles per hour, or 630 kilometers per second, in a direction that makes no sense relative to the universe's expansion. We are being reeled in. Think about that. The combined gravitational pull of all the visible matter around us cannot account for this motion. Something else, something dark and unimaginably massive, is out there. Scientists have given this mystery a name that is as ominous as it is accurate: the Great Attractor. It is a puzzle that challenges our understanding of the universe's structure and our own cosmic destiny. Where are we going? And more importantly, what is pulling the strings? The search for this answer takes us to the very edge of perception, behind a veil in the cosmos from which no light can easily escape. Part 2. The first clues emerge. The story of the Great Attractor begins not by looking at the stars, but by listening to the echo of creation itself. In the 1960s, scientists discovered the cosmic microwave background, or CMB. This is the faint, residual heat of the Big Bang, a baby picture of the universe, and it is remarkably uniform in all directions. It proves the universe began in a hot, dense state. For a time, it was the perfect confirmation of our cosmological models. But by the 1970s, more sensitive instruments revealed a subtle imperfection. They found that the CMB was slightly hotter, meaning blue shifted, in one direction of the sky, and slightly cooler, red shifted, in the opposite direction. This is called the CMB dipole anisotropy. At first, it was thought to be a simple Doppler effect, caused by the motion of our solar system around the galaxy, and our galaxy moving within our local cluster of galaxies. But when astronomers meticulously subtracted all of these known movements, a huge, unexplained velocity remained. This residual motion, what scientists call our peculiar velocity, was the first clue that our entire galactic neighborhood was on a journey together. It was a shared, directed motion, independent of the universe's overall expansion. It was as if our entire fleet of galaxies, the local group, was caught in an invisible current. To confirm this, astronomers began a monumental task, measuring the distances and velocities of thousands of other more distant galaxies. They needed to build a three-dimensional map of cosmic flow. Using standard candles like Type 1a supernovae and the Tully-Fisher relation, which links a galaxy's brightness to its rotation speed, they painstakingly built this map. And the map told a terrifyingly consistent story. Not just our local group, but the massive Virgo cluster and dozens of other clusters across a region spanning hundreds of millions of light years were all streaming in the same direction. The evidence was undeniable. There was a single, dominant source of gravity out there, a gravitational basin so immense it was warping the local fabric of space-time. The Great Attractor was real. But the moment we knew where to look for it, we were faced with an even greater problem. We couldn't see it. Part 3. Deepening the paradox. The target was identified. The Great Attractor lay approximately 150 to 250 million light-years away, in the direction of the constellations Triangulum Australe and Norma. When astronomers aimed their powerful optical telescopes at this region of space, they were met with frustration. A thick blanket of stars, gas, and interstellar dust from our own Milky Way galaxy stood directly in the way. This cosmic blind spot is known as the zone of avoidance. Our flat spiral galaxy is like a dinner plate, and we live inside it. When we try to look out into the universe through the plane of the plate, the view is almost completely obscured. It's a bitter cosmic irony. The very galaxy that gives us life is blocking our view of the force that dictates its ultimate trajectory. For decades, this made studying the Great Attractor almost impossible with traditional telescopes. It was like trying to understand a mountain range while standing in a blinding blizzard. We knew something of incredible mass had to be there. The gravitational calculations demanded it. The mass required was estimated to be in the realm of 10 quadrillion solar masses, the equivalent of 10,000 Milky Way galaxies. This created a profound paradox. The evidence for the Great Attractor's pull was overwhelming, written in the motion of every galaxy around us. Yet the source of that pull remained shrouded in mystery. Was it a single supergalaxy of unprecedented size? Was it an impossibly dense cluster of galaxies? Or was it something else entirely? Perhaps a vast primordial filament of dark matter, the invisible scaffolding upon which the universe is built? The zone of avoidance wasn't just an obstacle. It was a challenge to our ingenuity. If we couldn't see through it with visible light, we would have to find a way to peer behind the curtain using other means. The quest to unmask the Great Attractor forced astronomers to push the boundaries of technology, to look at the universe in wavelengths of light that are completely invisible to the human eye. The secrets of our cosmic motion were hidden in the dark, and we were about to turn on a new kind of light. Part 4. The Promised Payoff. The impasse had to be broken. Astronomers realized that while visible light is easily scattered and absorbed by gas and dust, other forms of light are not. Longer wavelengths like infrared and radio waves and higher energy radiation like X-rays can penetrate the galactic smog. A new generation of surveys was launched, designed specifically to map the hidden universe behind the zone of avoidance. Projects like the Parkes HI Zone of Avoidance Survey used radio telescopes to detect the neutral hydrogen gas in galaxies, allowing them to map their locations and movements even when their starlight was hidden. X-ray observatories like the Rosat satellite could spot the hot gas that permeates massive galaxy clusters which glow brightly in X-ray light. Slowly, painstakingly, a picture began to emerge from the static. Like developing a photograph, the blurry shapes behind the zone of avoidance started to come into focus. They found not one, but hundreds of previously unknown galaxies. And at the heart of it all, they found it, a massive galaxy cluster, right where the Great Attractor was predicted to be. It was named the Norma Cluster. The Norma Cluster is immense, with a mass of about 1,000 trillion suns. It is a sprawling city of galaxies, bound together by gravity, sitting at the core of the mystery. For a moment, it seemed the puzzle was solved. The Great Attractor was simply the Norma Cluster, a giant but ultimately understandable accumulation of matter. But this is Mindbenders, and the universe is never that simple. When scientists calculated the total mass of the Norma Cluster and all the surrounding galaxies had uncovered, they ran into a new problem. The mass they could account for, it wasn't enough. It only explained about half of the observed pull. The Great Attractor was real, but the Norma Cluster was only part of it. It was the heart of the anomaly, but not the entire beast. This is where the scale of the universe truly begins to bend the mind. Astronomers realized they had to zoom out even further. What they discovered next would not just identify the Great Attractor, it would redefine our very definition of home. They discovered that our Milky Way, the Virgo cluster, the Norma cluster, and everything else caught in this flow were all part of a single colossal cosmic structure, a supercluster of galaxies, 520 million light-years across, containing the mass of 100 quadrillion suns. They named it Laniakea, Hawaiian for immeasurable heaven. The Great Attractor isn't a thing we are being pulled to. It is the gravitational center of the very thing we are a part of. We are not traveling towards a destination. We are simply flowing downhill within our own incomprehensibly vast home supercluster. But just as we were beginning to feel a sense of cosmic orientation, astronomers noticed something else in the data, a final twist that reveals the true, awesome scale of the cosmic hierarchy. What is the final answer to this cosmic pull? The full revelation is coming now. The profound conclusion. The discovery of the Laniakea supercluster was a monumental shift in perspective. The Great Attractor was revealed not as a monstrous object, but as a broad, flat-bottomed gravitational valley with the Norma cluster at its core. We and all our galactic neighbors are simply rolling downhill in this valley. This answered the what, but it opened up a much bigger why. Why does this enormous valley exist, and is this the end of the story? The analysis of galactic flows didn't stop. With the Great Attractor region now better understood as the center of Laniakea, astronomers could look at the motion of Laniakea itself. And they found the most mind-bending fact of all. The entire Laniakea supercluster, all 100,000 galaxies, including our own, the Great Attractor itself, is also moving. The entire structure is being pulled by something even larger, even more massive, lurking even further away in the cosmos. This is the final revelation. Meet the Shapley supercluster. Located about 650 million light-years away, the Shapley supercluster is the largest concentration of galaxies in our local universe. It is a cosmic titan, a true gravitational monster, containing the mass of more than 10 million billion suns. It is so massive that its gravitational influence is the dominant force in our corner of the universe. So the complete picture is a breathtaking chain of gravitational command. Our Milky Way is falling towards the Virgo cluster. The Virgo cluster and the Milky Way are falling towards the center of our Laniakea supercluster, a region we call the Great Attractor. And the entire Laniakea supercluster is being inexorably pulled towards the colossal Shapley supercluster. This is the final revelation. Meet the Shapley supercluster. Located about 650 million light-years away, the Shapley supercluster is the largest concentration of galaxies in our local universe. It is a cosmic titan, a true gravitational monster, containing the mass of more than 10 million billion suns. It is so massive that its gravitational influence is the dominant force in our corner of the universe. So the complete picture is a breathtaking chain of gravitational command. Our Milky Way is falling towards the Virgo cluster. The Virgo cluster and the Milky Way are falling towards the center of our Laniakea supercluster, a region we call the Great Attractor. And the entire Laniakea supercluster is being inexorably pulled towards the colossal Shapley supercluster. The Great Attractor, the mystery that puzzled astronomers for decades, turns out to be a middle manager in a cosmic hierarchy of unimaginable scale. It's not the ultimate destination, but merely a significant waypoint on a much grander journey. The search for one anomaly revealed a nested, interconnected structure to the universe that we are only just beginning to comprehend. We thought we were solving a local mystery, but we were actually uncovering the fundamental architecture of the cosmos. The zone of avoidance didn't hide a single object. It hid a paradigm shift. It forced us to see that the universe isn't a simple expanding sphere. It's a complex web of filaments, voids, and superclusters, a dynamic, flowing, cosmic river system. And we are not just floating in it, we are part of the current. The final mind-bending thought. So what does this all mean? We have a destination, or at least a direction. We are on a cosmic trajectory, a multi-stage journey towards the Shapley supercluster, a journey that will take longer than the current age of the universe. Our fate is tied to a structure so large we can barely comprehend it. This discovery completely shatters the old image of galaxies moving apart in a simple, uniform way. It replaces it with a far more intricate and elegant vision of a universe with structure, with direction, with watersheds and rivers of gravity. It implies that from the very first moments after the Big Bang, tiny quantum fluctuations in density were destined to grow into these cosmic superstructures that would one day govern the motion of trillions of stars. Is our motion destiny written into the fabric of space-time from the first second of existence? Think about our place in all of this. We live on a planet, orbiting a star, on the outskirts of a galaxy. That galaxy is falling towards a cluster, which is the center of a supercluster, which itself is being pulled across the universe by an even larger supercluster. Our identity is nested, level, within structures of astonishing grandeur. The Great Attractor mystery taught us that sometimes the most profound enigmas are not about finding a single monstrous object, but about understanding our place within a system far larger than we ever imagined. It reminds us that even when our view is obscured, even when the truth is hidden behind a veil of stars, the universe leaves clues in the most subtle of motions. The final mind-bending thought is this: we are not passengers on spaceship Earth. We are passengers on spaceship Laniakea, and our journey across the cosmos is not random. It is guided by the ghosts of matter and energy from the dawn of time, pulling us through the dark. What other cosmic currents are out there, waiting to be discovered? And what lies beyond the shapely supercluster, at the very end of the river? The search for answers has only just begun.
The world is full of fascinating paradoxes, isn't it? We hope today's facts truly bent your mind. If you're ready for more daily revelations that challenge the norm, subscribe to Mindbenders. Don't forget to ring the bell so you never miss a new video. Until next time, keep questioning.